Hey math kids, today we're going to talk about parallelism. So if we have a vector A, vector B that are parallel, we know that they don't necessarily need to be the same length or have the same magnitude, but everything about the vector, like the direction, needs to be the same. And so if we can just times B by something to get A, then they're parallel, or if we could times A by something to get B, then they would also be parallel. So let's try a problem. So it says find R and S, those are not vectors, when we're given vector A, which is 2, -1, R, and vector B, which is S, 2, -3. So we know that they're parallel. It's given that they're parallel. So we need to find that number that we could multiply them by to make one of them turn into the other one. So we're going to use the y value on both of them to figure that out. So if I was to multiply -1 by something to turn it into 2, it would have to be -2. And so if we're going this direction, so if I multiply this by -2, that tells us that S must equal -4. And that's when we go this direction. Now if we're going this direction, we would actually be dividing by -2. So if I divide this one by -2, I'm going to get an R that's equal to 3/2. And that's it on that one. On the next one, we have vector B, and we know the magnitude is 7. Wait. So, okay, I misread that, sorry. So, given vector B, and then we want a new vector that's length 7 units and in the opposite direction to A, which is defined as 2, -1, 1. Okay, so what we're going to do first is we're basically going to divide out the magnitude. So I need to find the magnitude of A, which is going to be 2 squared plus -1 squared plus 1 squared, which is 4 plus 1 plus 1, which is the square root of 6. Okay, so we know that the magnitude is the square root of 6. So what we're going to do first, we're going to change it into a unit vector. So we know this is square root of 6 units long, so we're going to first divide that. So we're going to have 2, -1, 1, and we're going to say it's divided by square root of 6. So now this has a length, so units, this has a length of just 1 unit. Because if you take something that is the square root of 6 units and you divide it by something that is the square root of 6 units, you will get just 1 unit. Okay. Now that this is 1 unit, if we want to make it 7 units, all we need to do is multiply it by 7. So we'll put a 7 on top there. So now this is 7 units long. The issue is it's not in the opposite direction. The way we turn it around, so we just put a negative sign out there. So now it's 7 units still, but now it's going in the opposite direction, and now we can call this B. Okay? Now we need to prove that given this and this and this, We need to prove that they're collinear. Okay. So what we're going to do, for them to be collinear, so if we have a dot, we need to be able to draw a line that goes through all 3 points. Now, from a vector perspective, we first need to know that they're parallel, because we would want the vector from here to here to be parallel with the vector from here to here, just meaning that it has the same slope. That's essentially all that parallel means. So we're going to do that first. But just because 2 vectors are parallel doesn't mean that the points are collinear, so we'll address that later. But first, let's just prove that they're parallel. So we're going to say AB and BC. So if we find AB, we're going to do B minus A. So 4, 0, negative 1, minus, 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 negative 1, 2, 3. And when we do that, AB is equal to 4 plus 1, negative 2, negative 4. Okay, now we're going to do the same thing for BC. And so 14, negative 4, negative 9, minus, 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 4, 0, negative 1. So that's 10, negative 4, negative 8. Okay. Now, they're not the same thing, but remember, if we can multiply by a constant, then we know they're parallel. So if I multiply this by 2, I'm going to get 10, negative 4, negative 8, and now that's the same thing. So we've proven that they are parallel. So AB is parallel to BC. But like I said, that could mean that it's something like that. Now, because they both have B in common though, there is no way to make these parallel without them being collinear, because they have to share B. So once we make that point, then we can say A, B, and C are collinear. And that's it. If you have additional questions, come to Math Lab. Until then, calculator.